Good evening, everybody. Today we're on the 7th video in the Dear Moody series. The series is about me, David Lipschitz, a humble, active citizen interested in energy and the environment and how we live in the fourth industrial revolution, saying to Moody's, please don't downgrade us in November. There's a lot of goodwill and good work happening in South Africa, a lot of embedded generation, a lot of embedded water, and I think that's what's making us be where we are, where we don't have load shedding and we don't have water problems. We do have water restrictions, and in fact the city of Cape Town next month, on 1st July, will change level 3 to level 1, saying therefore that the rations we get at the moment will be permanent, that we're never going to go back to where we were before. And where we were before was actually using half of the water of a first-class city. So without further ado, let's look at what we can look at today. So we started off with the 4 parts. The first part is called policy and law. The second part is called translation. The third part is called commentary, and the fourth part, hidden meaning. So we've just finished policy, and we're looking at, we had a bit of translation from Barbara Rudek last night, and now we're going to have a little bit of translation from me, where I'm going to look at the policy and the presentation that I did about virtual power stations and see where we get to. So I'm going to switch now to the slide. Okay, so this presentation was done by me in 2012, and I also loaded it in Slideshare. So I'm just going to show you where it is. It's on www.slideshare.net/David Lipschitz/building a virtual power station one-day workshop. And you can maximize it, and you can see that it has a number of slides, 181 slides, and so on. I'm not going to use this particular version because I want to use the version that I've got in PowerPoint on my machine. So I'm going to close this now, and I'm going to pause now because the fan has gone on. Hold on. Okay, the fan has reduced substantially. We're back online. I'm David Lipschitz, and we're looking at the virtual power station. We're going to look at 4 slides in particular, and we're going to go straight down to the slide about risks. So now, as you can see in the slide says that a no-risk project has got a risk factor of 0, cost assumptions, lead time assumptions, security of supply, operational. So what this means is we know exactly what it's going to cost. The scoring will be 0. We don't know what it's going to cost. The scoring will be 3. Lead time, we know exactly how long it's going to take. Scoring will be 0. We don't know. Scoring will be 3. Security of supply, will we get security of supply? If it's low, no. If it's high, yes. And if the operational risk, if we have security of, if we know exactly what the operating risk is going to be, then it's low, and otherwise it's high. So if we take a look at powerized coal, then cost assumptions, they're saying 1, which means we know exactly what it's going to cost. That's not true, because as we've seen in the past 10 years with Medupi and Kusile, actually it probably should be 10, because we're currently costing 3 times as much as it should have cost. Lead time, well, we're not quite sure how long it's going to take, which is true. And security of supply, well, we know we're definitely going to have security of supply, but again, it's coal, and people don't want to invest in coal, so do we have security of supply? Operating risks, there are high risks. That gets a 7 out of 12. Then we go down to wind. Wind gets a 2 out of 12. Cost assumptions, well, we're pretty sure what it's going to cost. Lead time, we know exactly how long it's going to take. Security of supply, well, they say, well, it's a 1. So it's a low risk that we're not going to have wind, and operational risks, none. So wind gets a 2. Nuclear, and South Africa didn't want wind back in 2010. They didn't want PV power either. And then costs for nuclear, well, we don't know what the costs are going to be. Lead time, we don't know how long it's going to take. Security of supply, well, we say it's the same as wind. We know we can get the nuclear power. Operating risks, we don't know how complex that's going to be. So nuclear gets 10 out of 12. It's very high risk. Wind, 2 out of 12, very low risk. You would have thought that the government would have gone all out with making wind, but that's not what happened. The next slide says what things are going to cost, and for 9.6 gigawatts of nuclear, we don't have nuclear on the agenda at the moment, but you can see this line over here is Flamanville, which is one of the French projects, which is way over budget. Okay, let's go down to slide 25 now. Slide 25 talks about net metering, also known as NEM. It says the avoided costs, including the sum of all costs that the utility avoids as a result of customer generation to the grid, including energy purchases, generation capacity, resource adequacy, line losses, transmission and distribution capacity, air pollution permits and offsets, ancillary services, renewable energy purchases. This is from an evaluation that was done in January 2000 by the California Public Utilities Commission, otherwise known as CPUC. It was a report done by them. I have a copy of the report. You can look for it online. And it basically says that actually, whilst the general government said, well, and the utilities thought that net metering would actually cost the utilities money because the utilities lose income, actually net metering saved the utilities more money because it meant they didn't have to build infrastructure, they didn't have to build capacity, and they didn't have line losses, and a person could supply the grid with energy and buy the energy back. And if you set up the tariffs properly, then there's no reason why everybody can't be happy. It facilitates private investment. If we're at grid parity, it makes sense. Grid parity means that the end user can make electricity cheaper than they can buy it. And initially there was going to be photovoltaic panels without batteries, and we've already got to grid parity in South Africa with that, and we're soon going to be at grid parity including batteries, which means that a homeowner or a business owner will be able to make electricity, including having batteries and a generator, cheaper than it is to buy electricity from Eskom. It says it facilitates job growth, which in the USA is 10 times faster than the economy as a whole. 70%, 5% of installation jobs are local and cannot be exported. Now this is only part of the picture. If South Africa's 2 new power stations were running and another potentially 10 gigawatts was on the grid, then approximately 4 million people would have jobs because of that. So in actual fact, South Africa's jobs problem is fully the cause. The reason for the jobs problem is because of Eskom not providing electricity. And therefore we don't have electricity, for example, for desalination. We don't have electricity for jobs. We have a big problem. And let's go and look what that problem is costing. We're going to go now to slide 75 and 76. You're very welcome to look at Slideshare for these slides. You can also email me, david@mypowerstation.biz, and I'll send you a copy of the presentation. So, Eskom wants to borrow 2.3 trillion rand over 20 years to fund the new electricity fleet. And just to tell you, every single power station in South Africa will have to be replaced in the next 20 years. So this is basically the cost of what the power stations would be to build. Assuming we could borrow 10% over 20 years, we can't borrow 10% because our investment grade rating is already low. I think our borrowing is about 16 or 17%, and if it goes to junk status, it could be as high as 20%. But if it's 10% over 20 years, take off 2 noughts from here and you get 23 billion rand per month. So the people of South Africa will be paying for their new electricity fleet if we follow the old 20th century paradigm of coal, nuclear, oil, gas, and hydropower stations. There's 50 million people in South Africa. There's 7 million taxpayers at the time I wrote this. That was in 2012. There's currently closer to 3.5 million taxpayers. And at that time, it would mean that 3,285 rand per taxpayer per month. If you double that, we're looking at 7,000 rand per taxpayer per month for electricity costs. And that's for capex only. That's without even getting any electricity. Maybe there's a better way of looking at things. We were meant to spend 125 billion for Kusile, and it's currently 250 billion. But let's say it's 125 billion. But 125 billion, it's a big number. Let's break it down. It's 12.5 million, 10,000 rand solar water heaters. If you multiply 12.5 million by 10,000, you get 125 billion. Kusile is going to produce 4.8 gigawatts, and you would need 12.5 million solar water heaters would replace 20 gigawatts of electricity. So in other words, spending the 125 billion on Kusile makes 4.8 gigawatts. Spending the 125 billion on 12.5 million solar water heaters replaces 20 gigawatts of electricity. And solar water heating can be used to heat air and cool air and so on. So this is just a short explanation, looking at the costs, looking at what we wanted to do, looking at the numbers and saying, well, is there a better way? I believe there's a better way. I believe we should be going for it. I believe we are going for it from a decentralized homeowner power station point of view. And I believe that's what's going to save South Africa. Thank you.